Hi everyone, and thanks for joining us for another particular live webinar. This is Britt King. Today, Mauro Servienti, Sean Feldman, and Yves Goeleven will speak about service-oriented architecture in the cloud, including its capabilities, advantages, and pitfalls. We're going to hear about why and when to move to the cloud, why a layered architecture can't be moved to the cloud, why we need a message-based architecture, and how the cloud can help us scale out. Mauro, you're up first. Take it away.
Thank you, Britt, and welcome everybody. And as Britt has already told, we are going to introduce some concept about Microsoft Azure. Then we move to why we should move to Microsoft Azure and the problem we need to face when moving to the cloud in general. And then we do a brief introduction on the messaging infrastructure. And speaking about what Microsoft Azure is, we need to divide Microsoft Azure into three main branches. What is called software as a service, that is basically a pay-as-you-go managed service that can be consumed as is. And in terms of software as a service, our responsibility is just to configure the service. That's it. We are ready to use the service. From the scalability and availability point of view, everything is automatically handled by the infrastructure, by the Windows Azure infrastructure, and it's just a matter of paying more or less as the more we use the service. And samples in this area are the Windows Media Services, the mobile service, or the Windows Azure ServiceBus. This is something that Yves will speak about in the following slides. Going down a step, there's the platform as a service system or branch that is a managed statelet platform, where managed stands for managed by someone else, not managed in the sense of a .NET system, whose role is to basically abstract the underlying operating system. And our responsibility when we need to develop something against the platform as a service system is just to build the application, to develop the business application that we want to be deployed on Microsoft Azure. And there's a couple of things that we need to take care when we need to deploy something that will be hosted as a platform as a service. And it means that our solution will be somewhat coupled to how Windows Azure works. It basically depends on the type of system that we choose, but there's just small things and nothing important at the moment. From the scalability and availability point of view, it's on demand or automatic. We can ask Windows Azure, just moving a slider, to increase the number of instances where our application will run on, and in order to provide more power to the end user, or can be configured as an automatic system triggered by events. Let's say that we have a memory pressure on an instance, and we can configure in Windows Azure to say, if for a certain amount of time memory is over that percentage, just scale the instances for me, increasing the number of instances. Samples in this area are websites, web role, and worker roles. Currently, websites covers all the other tools. And going down a step more, there's the infrastructure as a service that is the lowest levels possible as Azure users, and it's basically a managed stateful, in this case, virtual machines. Whose role is just to abstract the underlying hardware. We have no way to touch the real hardware where our machine is running, but we have a VM running in some sort of a Hyper-V based system. Our responsibility in this case is is everything. We are responsible to configure the operating system, deploy the business application, update the system, maintenance, update of the applications, backups, and stuff like that. The only thing that we do not need to take care is the operating system installation that is provided by the Windows Azure portal. From the scalability and availability point of view, we have an on-demand system, so we can ask Azure to increase the number of instances of our VMs, but obviously the installed application on the VM needs to support the fact that there's more than one instance running in the Azure data centers. One important thing to notice is that Microsoft Azure data centers are pretty huge. There's lots of physical machines. On each physical machines, there's several virtual machines running, and each virtual machine basically hosts at least one service. Can be one platform as a service, can be one service, can be a website or stuff like that. And each service is connected to the outside world and internally to other services via virtual load balancers or virtual networks. And given the fact that everything is virtual, in order to allow Azure data centers to replace hardware under the hood without interrupting the service, we cannot rely on a network being reliable and being always available with low latency, and especially we cannot rely on having a network topology known upfront and stable over time. Basically, what happens is that instances of services are moved around within data centers by the Azure infrastructure. This basically because the hardware fails all the time. Physical servers fails, hard disk fails, load balancer fails, network equipment fails. And from the Microsoft Azure point of view, it is something that we do not need to handle because everything is handled by the Azure infrastructure and the support guides provided by Azure, but it's something that we need to care about. In order to respect the Microsoft Azure SLAs, we need to have at least 2 instances of everything that we decide to deploy on Azure. That's because if instance 1 fails, for example, due to hardware failure in an hard disk failing, instance 1 should be considered lost, and instance 2 is still servicing the requests, and in the meantime, the Azure infrastructure is taking care for us of reimaging instance 1. Reimaging is an Azure term, meaning that a new instance will be created by the Hyper-V infrastructure, creating an equal virtual machine to the failed one, hosting the services we expect to be hosted, the service we designed. So basically we can say that in order to respect the Azure SLAs, if we have at least 2 instances of everything, we have a highly available system. Obviously, the more instances we have, the more power we have, and the less risk of failure or partial failure we need to face. Given the previous statement, why do we need to move to Windows Azure, to Microsoft Azure, or why should we desire to move to Microsoft Azure? Basically, Azure guarantees us the ability to scale horizontally, and especially being able to scale on demand. We do not need to be prepared up front from the infrastructure point of view to scale up. Basically, we do not need to buy upfront servers, hardware, equipment in order to be ready to scale up. But we just ask Microsoft Azure to scale for me. We do not need to worry about hardware management, and so basically we do not need to worry about long-term costs. And in general, we do not need to worry about the infrastructure at all from the IT and Ops point of view. It's just something that we configure via the Azure portal, and that's it. And for some scenario, the one important thing is that it's a pay-as-you-go service. So for example, for startups, it's an ideal scenario, so they do not have to pay upfront a lot of money to start their business. Given the fact that we live in an occasionally connected system with moving parts, because things fails and things are moved around, so we cannot expect that a service that we expect to be there is there when we need to call it. In the following scenario where we have a typical web front end issuing an RPC call to a shipping WCF service, that is the backend. If this shipping service fails, for example, because the Azure instance failed, what happens is that in a typical RPC call, we can lose information, and we need to handle failures and retries manually at the web front end. It's up to us, it's our responsibility to handle all the possible failures. And since we have a network with medium to high latency, a similar problem applies to the connection between the front end, in this case, and this shipping WCF service. If the connection fails or is slow or timeouts, we can lose information, or it can happen that we slow down the whole system because all the RPC call to the backend will be slow. So in a scenario like the one just presented, the only way to solve or to try to solve the problem is to move from a RPC code-based system where the system is driven by synchronous call to an asynchronous and distributed system. Given the fact that we have occasionally connected systems, moving and distributed parts, no reliable network, we should not rely on RPC calls to drive the system. But we need to move to messages that can be shipped to a remote service via a queue. And on Azure, a queue will be the Azure ServiceBus service or Azure queues, and Yves will introduce you to them. And so the previously presented scenario will be in Azure will be as following. Since we need to have two instances, at least two instances of everything, we now have two web front-end instances, number one and number two, that are connected to the Azure Service Bus, a queue system, a queuing system, a broker in this case, but we can think about a broker like queues from the high-level point of view. And both front ends posts messages to the queue, and on the other hand, there will be shipping endpoints. Endpoint is the service terminology in the NServiceBus world, that are competing consumer. They are connected to the same queue, and the first one that will consume the message will handle all the message business logic. And so we have shipping endpoint number one and number two. And now if one of the endpoints fails, what can happen is that the other one go on picking up messaging for us, so the service won't be interrupted. And on slow connections, nothing is slowed down because the connection between services, instances, and the bus, it's really performant. And so we have no problems at all because portions of the system are fast, and the communication being asynchronous guarantees us that everything flows as expected. If we zoom in to a shipping endpoint, for example, that receives a message, that shipping endpoint can be occasionally connected to another resource, a database in this case, and if the connection to that resource fails, in a traditional, even in Azure, using the Service Bus, if we go down using directly the Azure Service Bus or Azure Queues, if the endpoint fails, we need to handle the failure by hand. We need to handle by our own all the retry logic. We need to handle the retry count and decide what to do after n failing retries. So we cannot retry forever, basically. We should decide that, okay, we have retried for 10 times. Now we need to reply back to the original sender to provide feedback. But in order to know who the original sender is, we need to have a way to track it. And from the transport point of view, Azure, the Service Bus or queues are just the transport. We do not have all these informations. And so now let me give the presenter to Sean that will introduce us to what NServiceBus can do for us when running on Microsoft Azure.
Thank you, Mauro. So what we will be looking into is NServiceBus with Microsoft Azure or an NServiceBus on Microsoft Azure, and the benefits that NServiceBus is providing to us out of the box to take advantage of Microsoft Azure. First of all, focus on what and not on how. What we really want to focus during normal development is on the business challenges and problems that we have to solve, and not necessarily the Azure infrastructure or creating yet another implementation of how to handle certain things that have been already implemented. And ServiceBus can help with that in terms of handling transport details for us. It abstracts various transports. It will send for us and receive messages either over storage queues or ServiceBus, and by doing that it takes a significant portion of work away and solely allows to concentrate on the business problem itself and the challenges that we have within that domain. It will handle large and binary data over Azure storage blobs, which simplifies the concept of attachments or large messages, which we know are not an easy task to handle on a raw Azure storage queues or ServiceBus. Also, ServiceBus will handle retries and failure logic. So everything that we know from NServiceBus, such as first-level retries and second-level retries, run exactly the same way on Azure. And also the concept that is native to NServiceBus but is not to Azure is the error queue, where we can take it for granted and leverage for failed messages. NServiceBus will also provide auditing in terms of auditing queue and auditing messages to be able to reconstruct what happened over the time. Again, a concept that is not native to raw Azure, and just by trying to build it on your own, you're spending time on recreating something that NServiceBus provides out of the box. Another aspect is long-running processes in real life. As an example, we can look at checkout process when someone puts an order. Usually it involves a complicated logic that is spent over time with various events, synchronization over certain things, establishing connections to third parties, ensuring that we have all the pieces of data that has to come together in order to proceed to the next step. Usually it involves persistence, it involves timing things, it involves events. It can quite quickly become very overwhelming and complex. On Azure, Azure is a platform that you can develop on, but it doesn't really provide a service out of the box that would handle it in a nice and simple manner the way NServiceBus does with something that it calls sagas. We really want to focus on the process itself and not the Azure technicalities. To allow so NServiceBus will implement sagas on top of Azure. Azure closest equivalent that we could compare NServiceBus sagas to would be probably worker role, which would be a long-running process similar to Windows service. NServiceBus saga timeouts feature has no equivalent with worker roles. Usually it will require custom timer operations and some sort of persistence as well. Again, custom code to be created on top of Azure. NServiceBus saga persistence is handled also automatically for us. Again, Azure has no equivalent for worker role for such a concept. It's traditionally custom persistence code, either with, depending on what kind of route you're taking, platform as a service or infrastructure as a service, but it would end up with Azure SQL or some other sort of database on Azure or on premises using hybrid connection. The story of endpoints, which we know from NServiceBus, we want Azure scaling model along with NServiceBus easy hosting to allow to leverage endpoints and host those, which NServiceBus will provide on top of Azure for both web and worker roles. NServiceBus will allow to debug endpoints locally, and I would like to highlight this one because it can do it with or without emulator, where with traditional cloud services, in order to debug it, you would normally have to run it on emulator locally, or alternatively, you would be connecting to the cloud service running on Azure itself, connecting debugger, Visual Studio tools to that instance, but it usually associated with slow communication, and any change that you would want to redeploy would take time, just because a new instance would have to be spinned up and swapped with an existing. So where NServiceBus is really strong, that it allows you quick and efficient deployment without abstraction layer on that emulator introduces. NServiceBus can host multiple endpoints in a single role. And this is an important point because Azure has absolutely no equivalent to this, which results in plainly significant money saving. Think of it as your traditional NServiceBus solution where you have several endpoints, assuming you would have somewhere between 3 to 5 endpoints. The moment you want to take those endpoints into the Azure, you would be forced to convert every endpoint to a role, which results in a role instance, meaning that you would have 3 to 5 role instances. Because Azure, in order to supply availability on Azure, you have to run more than a single instance of a given role. That means multiplying those 3 to 5 endpoints or role instances by a factor of 2, you ended up having between 3 to 6 to 10 role instances, which quickly adds up. And when at the end of the project, or when you're running in production and suddenly your bill spikes up, that is not something that business appreciates. And this is where NServiceBus can actually reduce the cost, which Azure cannot do it on its own. When developing applications with NServiceBus, we're used to meaningful messages, and what we want is those meaningful messages to be tied to the domain of the problem. NServiceBus will decouple messages from the infrastructure because Azure messages are coupled to transport. They're extremely technical. NServiceBus will also provide the abstraction that is nicely landing on your application, which is commands and events. Azure has no such concept because all of the messages are generalized transport messages only. And the case study that I'm going to quickly present is about Travel Alberta, and one of our first applications that we decided to build in cloud with Microsoft Azure, and some of the requirements and learnings that we had during that process and the learnings that we had. So the application itself, or the service, small service, which is email sign-up service, is fairly straightforward with business requirements that were allowing visitors to sign up, modify their interest through the subscription and unsubscribe. The second important key item was to never lose visitor information, just because when visitor is coming and they're willing to sign up, that's a single opportunity to get their information. Otherwise, they might change their mind and go away. So if we got their information, but somewhere in the middle, lost that info and cannot reproduce it, we will never be able to get it again, which means from a marketing perspective, we're losing a customer. The technical requirements were to integrate with a few third parties. Among those were ExactTarget, which is used for mailouts to keep the data, and some other things. Support desk, just because the data that is coming into our system is not necessarily always clean. We also operate in several markets. That means the data can be specific to the country or the market where the visitor is coming from, which means data is not clean, and not always it's possible to ensure the cleanliness of the data. So some data will fail our process and needs to be received by support desk. Account for service disruptions, that always happens. We've learned over the time, both on premises and later with Azure, that services fail everywhere. We needed to ensure that we're not losing data. We needed to ensure that we can run, and we need to ensure that we can easily solve those problems. That's where NServiceBus really helped us a lot. high availability, which was obviously virtue of Azure and proper architecture where NServiceBus landed nicely. And one other technical requirement that was very important, last but not the least, minimal IT involvement. As a small development group and not a big organization, we had this requirement up front that infrastructure team does not want to get involved every time there is an issue. We needed to be able to troubleshoot things ourselves. We needed to create a solution that is low maintenance solution, which we did with NServiceBus and Azure in conjunction. The lesson that we learned were quite interesting. The two most important ones were the gradual learning curve. When evaluating Microsoft Azure early in those days, it seemed like there is an overwhelming amount of details that one has to be familiar with in order to build a basic solution. After using a little bit NServiceBus in the past, it seemed very natural to take the abstractions, to take the mechanisms that NServiceBus provides out of the box and apply those on top of Azure Transport, on top of solution we were building in Azure. And that's where the gradual learning curve for Azure happened to us through NServiceBus. The second learning that we had was around tooling for raw Azure, which is a challenge on its own. It was and it still exists as a challenge. Microsoft does provide great services, but we had difficulty to use raw Azure as is to troubleshoot some of the challenges, to look into the failed queues, to audit those messages. And this is where we're at the point of looking into a particular platform to be that possible solution to complete the whole circle. And I will give the mic to Yves, who will expand and extend on Azure itself.
Thank you, Sean. Yep, and yeah, well, everything goes well, you can see my screen now. So I'm one of the developers on the particular platform, especially specialized in the Azure transports. I wanted to take you into a deep dive into the different transports that we support and cover a few topics that have not been discussed so far. Basically, there are two native transports supported in Windows Azure and also both supported by NServiceBus. Those two transports are Azure Storage Queues and Azure ServiceBus. And as you've seen before, one of the key aspects of working in a cloud environment is that you should rely on retries a lot. And both of these transports actually provide us a retry mechanism, which is called queue peak log. And that's used instead of relying on local transactions. Queue peak log basically means I put a message on a queue, I will peek at it, and I will exclusively reserve it for myself while processing. And once I'm done with processing, I will delete the message. If I do not, or if I'm not able to process the message in the allocated time, then the Azure ServiceBus or the Azure Storage Queue system will automatically make the message available again for another node. So it works a little bit differently than what you're used to from transactions in the past. Now, we do have two native transports, and the question often pops up, well, how do I choose? What are the criteria to choose one or the other? So let's dive into that first. The first transport I will cover is what we call Azure Storage Queues. Actually, this is a storage infrastructure. So it's a construct in the Azure Storage Service, where you also find Azure Table Storage and Azure Blob Storage. This means that it is actually designed to be highly reliable, we even say extremely reliable, because it has failover capacity across different data centers by default. So you will have at least 3 replicas of your queue in your own data center, and you have 3 other replicas in the same queue in another data center. within the same geographical continent, basically. And the second important aspect of the storage service is that it's extremely cheap. So handling or sending 1 million messages through an Azure storage queue will cost you about $1. And it's also extremely big. So current storage accounts can hold up to 500 terabytes of capacity. And there is, as far as I know, no individual limit on Azure storage queues themselves. So in theory, you could fill up a queue with 500 terabytes of messages. So those are very desirable features. It's extremely reliable, very cheap, and can be used. It's also easily accessible. It's HTTPS based. That's also its downside. It has quite a lot of latency when it's compared to, for example, service.
Yves, could I interrupt you for just a moment, please? Could yes. We're just getting a lot of chat coming in saying that people are having difficulty hearing you. Could you maybe just adjust your microphone, maybe a little closer to your mouth? Or?
Okay. Is this better?
It seems better.
I'm holding it to my mouth now.
I'm getting yeses from everyone, so thanks for that.
Yeses, okay. I like yeses. So if you did not understand something, do not hesitate to put it in chat. Well, we can cover it afterwards. So where did I end up? Okay, the TTL of messages in the Azure Storage Queue, this might be surprising, but you can only store data in there for 7 days. I say that it's surprising because it's actually a storage construct, but you cannot store data in there. So you have to process the data after, at least before the 7 days passed. Okay. So let's continue with the second service, so Azure ServiceBus. Azure ServiceBus is actually a real broker service. It's also highly reliable, but only within the data center by default. You can set up high availability across the data centers, but then you're a little bit on your own. The SDK helps you a little bit. We can do some things for you, but it's still a little bit of a manual process. On the upside, it does support more internal constructs for doing messaging. So it supports queues, but it also has topics and subscriptions. So that takes some of the work that we typically do in NServiceBus, we can automate by using Azure ServiceBus. And ServiceBus abstracts this for you. You also have subscriptions in Azure Storage Queues, but then it's our platform that's actually handling all the details for you. Well, we can delegate that to Azure ServiceBus. Now, besides that, there are also a lot of additional features that come in handy from time to time, like automatic deduplication. We can enable sessions to send messages always to the same worker node. We can use partitioning to increase the throughput. We can rely on deferral features, dead lettering features, etc., etc., etc. So it's a lot richer environment than Azure Storage Queues. The capacity itself is a little bit less, so you can only store up to 5 gigabytes in a single queue. So that's something that you need to think of when you fill up your other queue, for example. It's also TCP based. By default, it supports SMBP, which is a proprietary protocol for the Azure ServiceBus environment, but it also supports AIMQP, and that's a very interesting one. This is AIMQP 1.0. So if you have read the spec one day of AIMQP, you know that there are multiple versions. So you have to look at 1.0. The upside of this is that it has a lot lower latency than, for example, Azure Storage Queues, because it can keep its connection open all the time. It can continue polling and reading messages. It does not have to poll every second. It can just keep the connection open for like 5 minutes and wait for messages to come in. The TTL on the messages is also unlimited, so you can keep messages around as long as you want to. This is not the default when you manually create a Azure ServiceBus queue or topic, but you can do it by code, and NServiceBus is actually doing this, so we keep the messages around. It's also relatively expensive in that sense that it costs $1 for 1 million messages to send to. So this is relatively a lot if you compare it to Azure Storage Queues. A remark here, it has been announced that the pricing will change, so there will be a limited version of Azure ServiceBus that only supports queues, but that will have a lot less pricing in the future, and that will be interesting. If I'm not mistaken, this pricing will come online in September 1st. So those are the two different transports that we have. So depending on the features that we need, especially latency, capacity, the TTL, we will decide for one or the other to choose from. Okay, then besides the two transports, we also fill in the gaps if one of the features is missing in one of the other transports. And so, for example, subscriptions, if we use storage queues as a transport, then we will fall back to Azure Table Storage as a persistence layer for these subscriptions. While if we use the Azure ServiceBus transport, then it's actually the native subscription on the topics that we're using. So we can delegate it to the ServiceBus transport. For sagas, Sean talked about that before. What we're actually doing is we're using Azure Table Storage for persisting sagas, and we are creating by default one table per saga type. So every saga, which is typically an endpoint on its own, will be persisted in its own table. So this is nicely separated. To support timeouts, also this only applies to Azure Storage as used as a transport. Then you will see a complex combination of two tables, two queues, and a blob container. The two tables are there, one for the manager, so that the manager can track its own state for how long it's or which timeouts is already sent. And the other table is to actually contain the timeout metadata for the messages that need to be sent. The two queues are also for communication between the endpoints and the timeout manager. And the blob container, this will soon disappear, but this is backward compatibility. In the past, it was possible to manually add state to a timeout message, but today that's not required anymore. The data bus feature, both transports actually do have limits on the message size as well. You can only send 256 kilobytes of data for each message. So if you want to send bigger files or bigger properties, then we have this feature called the data bus. The data bus itself is implemented by means of a blob storage container. We will handle all of the details for you for both transports. Okay, one of the questions I often get as well in more advanced scenarios is, well, how do we actually cross data center boundaries? Because Azure is a global service and it's very compelling to deploy a solution across different data centers. There are multiple reasons for that. One could be failover, but another one could also be to bring it closer to your customers or closer to the users. Now, in general, we try to keep everything as close together as possible, because obviously it's not, well, there is a lot of latency when you go from an endpoint hosted in Western Europe and you would put your data in north of US. Well, there's some distance between, so we don't want to incur that latency. But we do want to cross data center boundary from time to time, explicitly. And in order to support that, we can actually specify at any place that we define an endpoint. We can also specify another connection string. Well, by default, every endpoint can only listen to one specific ServiceBus namespace or storage queue, storage account. But it can send out information to others. So you basically deploy the same endpoint in multiple data centers. You use different connection strings for it to listen on. So you can reconfigure it by means of the configuration system of Azure. And then when they communicate with each other, you specify the other connection string from the other data center in the message mappings part behind the @ sign. Right. This works for both sends and subscriptions, so this will automatically be propagated for the both of them. Okay, now I'm going to hand back the presentation to Mauro to talk a little bit about a particular platform.
So, here we go again. As you may imagine, having, as Sean and Yves outlined, having a lot of different services communicating in one to each other in an asynchronous manner introduces a little bit of problems, hiccups, much more than problems, into understanding how the system is behaving now. So we needed to find a way to detect what's happening in the system, what is where, and what is going on, and which endpoints are running, which endpoints are having issues, where messages are, which is the state of each saga that is running in the system. So basically we need to find a way to monitor the entire system. And given the fact that, as Sean outlined before, from the Azure point of view, there is no tools other than a sample that Microsoft provides to us to monitor the ServiceBus. There is no tools to monitor what's going on in a system based on the Azure ServiceBus or the Azure table queues. We, as particular software, provides what we call the particular platform that builds on top of the auditing feature of NServiceBus that Sean presented before, and we can monitor the entire system that is connected through queues, and we provide two high-level tools. The left one called Service Pulse, that is much more a DevOps tools that can show us heartbeats coming from endpoints. So endpoints can communicate with Service Pulse saying, basically, I'm alive at each interval, saying I'm still alive. We can deploy custom checks to endpoints. So basically, we can introduce custom checks that says, okay, I am the endpoint, the shipping endpoint, I am alive, and I can communicate with my database, I can communicate with the credit card service, I can do that and stuff like that. We can introduce alerts, so from the Service Pulse UI we can see what's going on and we have alerts flowing in, and we can see failed endpoints and especially failed messages. So we can keep track of failing messages, and we can do one amazing thing, that is reply a failing message. Because it's something that we have not outlined before, that is that when we have an error queue and something fails and go through all the first level retry and then go through all the second level retries, if it fails both retry steps, it will be moved, the failing message will be moved to the error queue. And from Service Pulse, we can pick up the failing message and ask to the system, please reply this message for me. So basically, put this message back in the original queue where it failed the last time, supposing that we have solved the problem, and now the message should behave as expected. So basically we have a never failing system where what can happen is that in the worst scenario things are happening later than what we expect. And from the developer point of view, the DevOps, more the developer point of view, we have Service Insight, that is a desktop tool that allows us to visually track messages, where messages are, what's the path that a message has done into the system to reach a certain destination. Touching each message, we can see message details, so properties, headers, the body of the message. And we can view this current state of each saga running in the system, which messages has already reached the saga, which events has been published by the saga, and the overall state of a single saga. So we have the two main tools that allows us to have full control on the overall system and keep track of everything, even if the system is distributed, asynchronous, and is running out of our control because it's hosted by someone else, in this case by Microsoft Azure. And I think we are fine. I'll move back the mic to Britt so we can handle the Q&A session.
Sure. Thanks, Mauro. So the first question comes from James, and he asks, what is the licensing model for Azure deployed solutions, especially with teams testing multiple instances of the application? Mauro, Yves?
Okay, here I am, and I was fighting with, sorry guys, it's something I need to check at the moment because I'm not a license expert, but if I recall correctly, the current licensing model is that we license the developer. So basically each developer should have a license, and then the developer can deploy how many endpoints he needs to deploy in a testing environment and production environment too. So.
Great. The next question, are the NServiceBus Azure components compatible with NServiceBus 5 now?
Yves?
With NServiceBus, yeah. With NServiceBus 5, yes, we have released betas of NServiceBus 5 as well as the Azure 6.0 versions. Also are compatible with the 5.0 of the core.
Okay. Next question. Can you use SQL Azure for persistence instead?
Yes, you can. You just use the regular SQL persisters, which is basically based on an Hibernate. The only thing that is recommended to do is to take the specific and Hibernate connection, which has built in a retry, because obviously it's also a service running in Azure, susceptible to low latency. So retry is important, but this has been provided by the Hibernate framework itself. So it should be supported just out of the box.
Okay, the next question from Robert. Is it possible to send on-premise messages into the NServiceBus Azure queue system?
Yes. Yes. So the Azure's transport assemblies themselves are decoupled from the hosting infrastructure. So you can host them either in the Azure hosting infrastructure, which is host and stuff, or you can use them directly from a regular NServiceBus hosting endpoint and to have communication that way.
I would like to add to that during development that we have gone through, the first thing that we tried before even getting into cloud services themselves and spinning up role instances, we actually used emulator for storage queues to see how it works, and also try to run it for debugging purposes some of the code locally while using the real Azure transport storage queue transport, basically connecting on-premises running solution with Azure.
Yeah, and actually it works better to use the online version of the storage queue or the ServiceBus queue than it would be to use the local emulator.
Yves, would you mind moving that microphone closer again?
Yeah,
Sorry,
I'll move the microphone. I'll repeat. So actually when you develop, given that you have an internet connection, it's actually easier and more performant to use a queue remotely in the cloud than it is to use it locally.
Okay, so the next question from James, he's kind of talking about how the configuration differences between Azure websites and cloud services are challenging. So he's asking, and also some aspects of NServiceBus expect to use the default transport, which is hard to configure for Azure. Has this improved, or will it improve in ServiceBus 5?
Yes, this changes in ServiceBus 5. There you need to be explicit about the persisters as well as the transport. And that will be easier. There will be no automated fallback anymore to Raven like you would have in the past if something would go wrong. So this story has definitely improved a lot.
Yes, one thing I'd like to add about the first part of the question regarding the difference between websites and the rest of the roles on Azure is that be careful when using websites, because basically given the fact that websites can be run in a shared environment or an exclusive one, they may behave differently and the application may have different permissions. If you need to have full control of what's going on, move to a web role that has less feature but allows you to set up custom scripts that will be run whenever the role is started up by the Azure infrastructure, and you can configure the machine as you want. So you basically can set up permissions, create users and stuff like that, things that cannot be done in the websites.
Gert asks, are the diagnostic tools such as Service Pulse, are they also supported on Azure?
Yes, they are. But they are to be deployed in Azure virtual machines or locally. That's also an option. So they are not part of the cloud services, but they're part of Azure VM. And besides that, they are compatible with the transport, so you can monitor your Azure instances.
Dean asks if there are any asynchronization applications where NServiceBus on Azure is not the best fit.
Good question. I have no immediate answer for it, so somebody else can take it then.
Just from a customer perspective, we chose NServiceBus for the fact that we needed to handle the asynchronicity problem. So it really depends on particular problem that given person is trying to solve. In general, when we're talking about distributed messaging and asynchronous, NServiceBus proved itself as a very strong player in this field.
Robert asks,
generally speaking.
Oh, sorry, Mauro.
Sorry, no. Just an overall consideration. Generally speaking, what we can say is that if we need to go to the cloud, maybe we are not doing that because of pure performances, and but we prefer to have the cloud support, the scaling story, the asynchronous distributed things, the ability to not being required to handle failures and things like that. And so if you are looking for pure performances, maybe an asynchronous system is not what we are looking for. It really depends on the scenario, so it should be analyzed in depth, every single scenario.
So Robert asked the next question, when will NServiceBus 5 be available?
I suppose
it's available on beta today, so you can play with it. When it will be released, that depends on several factors, so we can't commit to anything yet.
We'll just wait a few more seconds, see if there's any additional questions coming from the audience. Okay, I think that's it for today. I just wanted to point out that we'll be making this recording available to everyone who registered, and then we'll be putting it up on the site as well shortly. So look for an email from me with a link to the recording. I also wanted to make mention that NSBCon New York is only a month away. So it's the two-day conference. It's going to include a mix of sessions on distributed system development from our team, our partners and customers. Carl Franklin and Richard Campbell from .NET Rocks will be there too. And of course, top speakers like Udi Dahan, Oranini, and Ted Newart as well. So go to nsbconnyc.com to learn more about it. We still have discount tickets available until Friday, this Friday, August 29th. Well, that's it for today. On behalf of Mauro, Sean, and Yves, this is Britt King saying so long for now, and see you on the next particular live webinar.